So welcome to Dear Blue Team. This is basically advice from someone with forensics experience to help expedite your capabilities within DFIR, DFIR, forensics, whatever you want to call it. So before we get started, the thoughts and opinions are mine and not those of IBM. The reason I say this is because I'm a senior security architect at IBM. Outside of the forensics world, I'm the 2017 DerbyCon Social Engineering Capture the Flag winner. My team, the Password Inspection Agency, got third place in last year's NOLACon OSINT Capture the Flag. I've got some certs. I'm a regular Forbes contributor. I'm currently under contract to write an OSINT and social engineering book with No Starch Press, probably fourth quarter this year, first quarter next year. And I've started offering some OSINT training via what I call OSINT Associates. So why this topic and this talk? Basically, in the process of going through SANS Forensics 508, the Advanced IR Forensics and Threat Hunting course, which is GCFA, I was reflecting on things. I apologize for sounding academic. At least I didn't say I was promoting synergy, right? But I was thinking about the things I had learned, and I came to the conclusion that some of these things you don't have to wait until there's an incident to actually do them. And if you do them in advance, it's going to make your life a lot easier. And I specifically want to say that this is not threat hunting. So that's in and of itself. We'll talk about threat hunting, but this is not on that topic. So basically, this talk is the outcome of those thoughts. So to get the baseline knowledge, just to make sure that we have a level playing field, what is DFIR? It's Digital Forensics and Incident Response. Often we'll actually confuse the terms incident response and incident handling. Incident response deals with all of the technical components, and the incident handling deals with it at a much broader level, dealing with things such as planning and the communications and all of that fun stuff. And that's sourced from SANS Internet Storm Center. So with the incident response process, the majority of what we're going to do here is based on the preparation phase. We'll do some stuff from lessons learned, a little bit with recovery, but the vast majority of this is in the preparation phase. So this process is commonly referred to as PyCurl. So you have preparation, identification, containment, eradication, recovery, and lessons learned. So as we dive into this, let's go ahead and talk about threat intelligence. So we have threat intelligence and cyber threat intelligence. If you're like me, the word cyber just makes your skin crawl, but it's the term for it right now. So basically a few questions associated with it. You know, where does this threat intelligence fit into our process? Well, in this case, with the process of this talk, it's not really going to fit in much at all because we're not really too concerned with that initially. Within the DFIR process, it's actually going to help you identify your adversary in some cases, or at least identify what you're up against in terms of what kind of malware, in terms of the vectors used and all of that fun stuff. Because, I mean, we're humans. We operate in patterns. We typically do the same thing. We wake up around the same time every day. We get out of bed. We go brush our teeth, hopefully put deodorant on. I've been to DEF CON, so I know there's a lot of people who don't. So if I ever start a company, my company swag is going to be deodorant. You heard it here first. But anyway, we do that, and then we get dressed or we hop in the shower. And I mean, we do things differently, but we all do it in a similar pattern. And basically, the threat intelligence is taking into account that pattern. So we have indicators of compromise that is nothing more than the technical pieces that go with that. That's going to be your mutexes, your regular expressions, any hashes or IP addresses or domains or email addresses associated with it. True threat intelligence that's actually actionable will take into account the tactics, techniques, and procedures, the TTPs of the adversary. So within that, that's taking it a step further. So moving forward, is DFIR and CTI the same thing? No. Which came first, the chicken or the egg? The DFIR or the CTI? The answer to that is yes. Because sometimes, if it's a known adversary, the threat intelligence triggers the response through your SIM or whatever, and then you go through your forensics process. In some cases, especially if you're in certain sectors, you will actually be on the bleeding edge, and you will produce threat intelligence that no one else has seen before. I like to refer to that kind of as the arms race. So you have your major firms and companies that are always trying to be the first to get the intelligence. So they've got all of their listeners out on the dark web. They've got all their honeypots, all that fun stuff, and they want to be first to drop it. So in that case, it's all a matter of who did it first. So when we talk about types of forensics, whenever I took this course, the only types of forensics I even really thought about was network forensics and file system forensics. I didn't even think about memory forensics. So with that, there are some tools you can use with this. And I'm a huge fan of not talking about tools that are expensive, or even for the most part, I don't try to talk about only free tools, especially when I'm talking about social engineering or OSINT. So with this, there's still a lot of things that are free that you can use. So SleuthKit, Autopsy. Autopsy is nothing more than a GUI wrapper of SleuthKit. You've got Scalpel and Foremost, which basically help you with file carving. Volatility can do some stuff with it, but not too terribly much. That's not where you're going to get the horsepower from it. And then FTK, there is FTK Paid and FTK Imager Lite. Within the networking side, your big one is Wireshark. I don't know if you can see the sticker, but I got a sticker on my laptop now that's Wireshark do with the whole baby shark thing. But you also have things like NetFlow. Your IDS is going to help you with that, and something I'm a huge fan of, and that's Network Miner. So within the memory forensics world, you have Volatility, Redline, Recall, which basically is a fork of Volatility that's now maintained by Google, and then FTK Imager. In terms of the operating systems, your big ones are going to be Sift and Remnux. There are others out there, such as Kane, the computer-aided investigative network environment. I don't think it's maintained anymore, but it is still there. There's a couple others that I'm just not familiar with. And then, to a limited capacity, yes, Kali can do it. I don't necessarily know that I would recommend that, but I have another talk that's called Social Forensication, where I actually weaponize digital forensics. So in that case, I break in as a social engineer, I steal a memory image, and then walk out the door, and I use Volatility. So it is in Kali, but I've done a side-by-side comparison of the built-in modules, and Kali just doesn't have quite the same verbosity and robustness that Sift does. So I would say use Sift for that. So in terms of threat hunting, we have our tools and techniques, our benefits, and the maturity. So in terms of tools and techniques, I'm going to say something that's probably going to be a major surprise, or probably not. The tools and techniques you're going to use for threat hunting basically are the same that you're going to use for a forensics investigation after the fact. You're going to use your SIM, you're going to use the tools, you're going to test for certain things, you're going to see what outcomes come from this. In terms of doing threat hunting, that's going to be forensics before the incident, whereas regular DFIR deals with forensics after the event. In terms of the benefits of it, it can certainly slice your incident response time in pretty dramatically. I don't want to say in half. It varies from organization to organization, but it will actually help you expedite that, and it will actually cut down on actual true incidents. So that's something to keep in mind. But the big key with this, and the reason why I'm not advocating heavily for threat hunting, is there's a certain level of maturity associated with it. Threat hunting is all based on finding the deviations from what is considered normal. Having been a consultant in the past, I think it would be very hard to go in on a, say, 40-hour engagement and truly understand what is considered normal in that environment so that you could find the delta. Sure, you could go in with some indicators of compromise and find a few things, but at the same time, you're not going to find quite as much because you don't know. They may have a job that runs on the 13th of every month that spikes their network traffic through the roof. If they don't tell you or you're not aware of that, you're going to waste 40 hours investigating why they have a network spike on the 13th of every month. You're probably going to try to quarantine that software as malicious until you find out otherwise. So I always advocate doing that on an internal team, not having an external entity do it. So doing the comparisons with DFIR, there are a few prerequisites. Typically, the prerequisite to do DFIR is to have an adverse event that would become the incident to respond to. It's reactive in nature. In the U.S., Jason Street makes a joke that Brian Krebs should not be your intrusion detection system. The FBI should not be your intrusion detection system. But typically, organizations that's how they find out. Brian Krebs contacts them and says, hey, I'm about to write an article about you. What do you have to say about yourself? Or the FBI knocks on your door. Hey, by the way. But anyway, with regards to the actual traditional DFIR process, you're trying to restore operations as quickly as possible. So you're not going to have the time to really sit down and do the analysis on the fly. You're going to have to get images, make backups, do whatever you need to do so that you can get this back up and running. Management may say that you don't even have time to make clones. Just restore from good, clean media and call it good. That may be the case. With threat hunting, everything deals with maturity, size, and capabilities. If you do not have probably, I would say, 13 or 14 of the Center for Internet Security Critical Security Controls, formerly known as the SANS Top 20, if you don't have 13 to 14 of those, chances are this is not for you. If you don't have a robust incident response process already and a dedicated team, it's not for you. It's proactive in nature. It's based around what's normal. It's going to consume that threat intelligence and try to find those anomalies. And within reason, it's not based on a time objective. Whereas incident response, the time objective is get this fixed, get it up fast. And that final bullet on the threat hunting side is the exact reason why I'm not an advocate for external entities coming in and doing threat hunting. So here we have our standard DFIR talk, and this pretty much is the end of the standard DFIR part before we actually catch the true Dear Blue Team stuff. So everything we hear, you should be doing logging, you should do it verbose, you should send remote logs somewhere, preferably to another host, whether it be another host within your own architecture or another host that belongs to someone else via the cloud. They can make you or break you. If you don't have the logs, you have nothing to bounce it off of. You're going to have to create your own logs. So within that, inventory everything. That's number 1 and number 2 on the critical security controls. Have an inventory of authorized and unauthorized hardware and software. If you don't know what's on your network, how can you defend it? How can you monitor? How can you know if it's something you actually need to respond to? There's a PowerShell tool called Consa that will actually help you with that in the Windows environment. There are a few things on the Linux side. I'm just not familiar with them at this time. But Consa basically will use WMI and interrogate your hosts and collect all the data, put it in a nice little pretty format, and you'll be on your way. But even with that inventory, it's like in the U.S., there's a commercial that comes on TV all the time. And this woman has had her credit score tattooed on her arm. And she said, I can get approved for that because I'm a 789. Not factoring in that it changes. So inventorying once a year around the time you have to do whatever you need to do for regulatory compliance, that's not an inventory. That's a single inventory. You don't have an inventory program. So you should do it frequently. If you use a vulnerability scanner, you could actually do discovery scans with that. It doesn't take anything more than a ping sweep, really. You could go a little bit further and identify the operating system, the host name, maybe, if you want to go that far. But you need to know what's there. And then have some sort of network time. If you're in the same time zone, if I'm not familiar with the time zone here, everything in Switzerland is in CET, correct? Okay, so within that case, if you operate exclusively in Switzerland, you could use CET or GMT. It doesn't matter. But if you open up an office in, say, Los Angeles or Rio, you need to have some sort of time sync. And that's one of the cases where your logs you might want to put your logs into GMT. You don't want to be in the middle of an incident counting on your fingers and your toes to figure out what the time difference is between here and there or wherever it happened. So something like NTP. You can't go wrong with UTC. UTC and GMT, same thing. Baselines, we'll talk more about that. That's going to be some meat and potatoes of this. So the soft-ish skills, you need to know who to notify, how to notify them, and when to notify them. I tell people through my awareness training that when you think something's wrong and you need to notify the security team, you need to know how to do it. If you've clicked on a fish, there's a good chance that sending a notification to the appropriate party via email is the wrong answer. Because if you've clicked a phish, there's a good chance that your email is now compromised, depending on what the phish is trying to do. So something to that effect, you might want to use smoke signals, carrier pigeons, text, Signal, WhatsApp, anything along those lines. Or if you're in the same office, just walk over face to face. But you need to define this. And I can't tell you the right answer because I don't know your organization. If you are keen in Morse code, you could do that as well. There's so many different ways. You don't have to do it a conventional way. You could just set up a hotline and say, hey, if you have a problem, call security. Here's the number. Like in the U.S. military, when I was active duty, next to every single phone, we had a thing called the bomb threat worksheet. It was nothing but a list of questions that if you answered the phone and there was someone calling in a bomb threat, it's a list of questions that you're supposed to ask the person on the other end of the phone. Why are you doing this? Who are you? What's going to trigger it? Is there any way I can talk you out of it? And you're supposed to talk this person in circles until you get all the answers and then continue while notifying someone else. Why are we not doing this for the forensics perspective? You don't have to call it a bomb threat worksheet. You could call it an incident response worksheet. That would probably be highly appropriate. And basically, the questions you might want to ask for this would be, what were you doing when this happened? Were you doing anything? If you were on a website, what website? List the exact URL. Did you click anything? Was this via email? Who sent it? These are all things that, as forensic investigators, we need to know. And if someone can tell us this, instead of us having to go synthesize the whole file system through SleuthKit, run the Plaso dump scripts against it, and then drop it in a timeline so that we can go and hopefully find the email header. If they can just tell us, think of how much time that saves. And at that point, you've got to really work with your user base, because too often security people, we tend to want to beat people over the head. And like there's people in industry now that are so quick to say users are dumb. You're dumb, dumb, dumb. And I mean, let's face it, there are dumb users. But the vast majority are not dumb. They're just not informed. They're not trained. And I actually put the burden more on us as security professionals because, A, it is our job to build robust systems that protect the user as much as possible, understanding that we cannot fully protect them from everything. And then for instances when we can't fully protect them, train them to the extent possible to be able to help protect themselves, protect the company, and report when it doesn't add up. And it's just like availability. There's no such thing as 100% availability. We hear a lot about 5 nines, right? 99.999%. That's what you're striving to get towards. You're trying to add an extra 9 to the end of that with the efficiency and security of your system. But it's a multi-pronged approach. So you want to be able to tell users within this worksheet the actions to take. Do you want them to shut the system down? That could compromise your memory forensics. Do you want them to send it into hibernation mode? That could be really good for you. Do you want them to log out, lock the screen, do nothing, unplug it from the network, unplug it from the wall? These are all things that you could do. I think of things from the perspective of, I'm on the phone talking to my 60-year-old mother, and I'm trying to convince her to do something. If I say, hey, on your desktop, unplug the network cable, every single cable is going to get unplugged. She's tech illiterate. I mean, that's just the way it is. But if I use a specific color network cable, say yellow, and I say, hey, if something happens, unplug that yellow cable, she can do that. I'm not saying that everybody needs to go off and buy yellow Cat 5 or Cat 6, but if you can use the same color uniformly or a series of colors, anything but black or white, whatever your ecosystem uses, use it. And the actions not to take. That's going to depend on your policies and procedures. Keep in mind that if this is something that's going to go to court, you want to maintain your chain of custody, your chain of evidence. You don't want to contaminate that because depending on what you're dealing with, the legal route may be exactly what you're pursuing. Like if you're dealing with something in, say, child pornography, that's inevitably going to go to court, and inevitably, I think the majority, if not all of us, could agree that we don't want to do anything that would allow someone who's a known pedophile to walk. So in that regard, make sure that you respect the chain of custody in that. So Something that I hear system admins do quite frequently during incidents. When an account becomes compromised, they change the password. Well, because the system admin changed the password, there's a good chance it's not going to hold up in court anymore. You've basically contaminated your evidence. So instead of changing the user's password, either deactivate the account or set the login hours to 0. Actually, if you want a free honeypot, I'll give you one right here. It's very easy. Conventional wisdom says to disable the built-in administrator account, right? That's what most security guides like. I know the US DoD's forms all say to do that, and I think the SIS benchmarks say the same thing. I'm going to tell you to do the opposite. Enable that administrator account. Set a very simple password that meets the minimum complexity required in your organization. Okay. Yeah, y'all are looking at me like I'm crazy. Set the logon hours to 0. So now in your SIM, you can actually set it up to where if you get an alert of any successful login from this account, you know something is compromised. The system from which it logged in on is compromised. Nothing can happen. It's a successful login, but they're not going to be able to go further and actually do any harm. But that's a honeypot you could run for free. Another thing, and this is from a scenario that I actually dealt with, a former customer, they had an RDP server running as a virtual machine on the public internet, not behind a VPN, logging in as administrator with a 4-character password. I can't make this up. So the company I worked for got called in to do incident response. So I drive to the location. It was about an hour away. And I'm like, hey, could I see the host? I want to look through the logs. I want to look through some other things. He's like, no. Okay, well, you're the customer. You're right. I deleted the VM. So if you're using virtualized environments for things like this, if something gets compromised, don't delete the VM. Take it offline, power it off, pause it, do whatever you want. Just don't delete it. Don't delete evidence. So now we're getting into the cool stuff. So memory analysis. That's what this is really the meat and potatoes of this. So you can do it various ways. To collect your memory image, you can use things like FTK Imager Lite, which is free. Recall can collect memory as well. Lime works for Linux. So Recall will work on Mac. And it is also integrated into Google Rapid Response, GR. Mandiant has MIR that also works. So there's various ways you can do it. There's no right or wrong way as long as it's compatible with your operating system. But then with regards to the actual assessment of it, you can do it with recall or volatility from the command line, or you could use redline from the GUI. There's a feature that went away in version 1.20, and that is the MRI, the malware risk index. So I tried to find a version of 1.14. I've not been able to find it from anything reputable. I even tried looking in the Google Cache, the Wayback Machine, everything. FireEye, Mandiant, they've taken it down. You can't find it. So if you know anyone who has it or has taken the SANS 508 course, it's probably on that thumb drive. So that version is 1.14. And basically what the MRI does is it's a little pie chart that goes to the left of everything that, based on certain heuristic checks that Redline does, it assigns a value between 0 and 100. And the higher it is, the more likely it is to be malicious or malware. So that's something that you certainly want to take a look at. So within memory analysis, the purpose, basically, we can spoof things all day, but if it's in memory, it's truth. You're going to find out what's actually running on the live system. Of course, you do have to have administrative privileges to be able to capture the memory, but we're going to find evidence outside of syslog which could have been tampered with, or anything else about execution. There are a few other files that we can look at that are somewhat protected, and we'll talk about them as well, but we're going to find that we can do things off-site and out of the system that will replace a lot of the Windows sysinternal process. And that's going to be plugins like procmon and procdump within volatility. We can cross-reference this. So, as with everything, if you see something in memory, you can see, does this correspond to something that happened on the network? Does this correspond with a file that we were able to recover using Scalpel or something that we see in SleuthKit? You can feed this into a timeline as well. So there's actually a plugin called Timeliner that will actually help you create a Plaso file that you can then append to your file system Plaso file, which that's log to timeline uses the Plaso dump format. And in doing so, you're basically able to see the two on top of each other. And then beyond that, you can assess your processes. You could do Windows registry analysis. Rob Lee, the author of the 508 course, he brought up a point that at this time, there's no known adversary that can spoof a registry key creation date. And if you know the specific registry key you're looking for, you can actually query that in volatility and get the actual creation date, and it will not be 1/1/1970. So you'll actually find out the real date that this was installed. And then, of course, there are plugins associated with finding malware. So talking about other capabilities and specific modules associated with those, you can do hash dump or Mimikatz directly out of this. I've tested it on Windows 10. It's not very effective with that at this time, with the two versions I've tested. But it's always the game of cat and mouse. Gentle Kiwi's always going to come up with something new, and then Microsoft's going to see it, fix it, and he's going to have to come up with something else. It's just the nature of the beast. You can look at rogue processes. So you've got PS tree, PS list, and PS scan. Within SANS, they also, I think you can get it from their GitHub. There's PS total that's going to take all of that into account, and it's actually going to create a graphic for you, and it's going to color code processes that don't look right that you need to take a look at. So that's something that can help you as well. You can pull DLLs, carve them. That actually works if you're trying to be a malicious actor as well, because then you can determine what DLLs are there. So if you want to do like a DLL hijacking attack, now you know which ones are there, so you can determine which ones are vulnerable. Carve processes. The get key, that's the registry key creation date, the timeline, and then known malware, malsysproc, malfind. There's a few others as well beyond that. So here's some other stuff. So those files I mentioned that are not in memory that you could still reference, here they are. And this one is the prefetch. And basically, it came out in XP. It's still in use today. And it just collects and stores specific data to help everything to run faster. Starts faster, basically. So it's a cache, if you will. If you go looking through a host and you don't see prefetch files, first, check your registry to make sure that it's enabled. Secondly, if it is enabled, there's a boo-boo there. You're probably going to want to take a file system image and try to carve those out using Scalpel or Foremost, because there's a good chance that they've been deleted. Another similar thing is called the shim cache, also known as the application compatibility cache. It's going to look at things, and it's not so much for speed, it's more for compatibility, but it's going to take certain data points like the full file path, standard information, and then the process execution flag, and it's going to actually store that in a file. So you can treat it very similar to prefetch in terms of your analysis. So other things with processes. And this is something that I wish I saw more of, and you could accomplish it with a very simple for loop. So determine which directories you care about. So in the Windows environment, I would say System32 and probably the user space at a minimum. But you can write a for loop. So for file in directory or in directories, take an MD5 hash of the file, write it to another file. This is basically file integrity monitoring. You take the hash of it. It doesn't matter. You don't worry about, I'm using MD5. MD5's weak. It can be broken. No, it doesn't matter, because we don't care if there's a collision. We just need to know what the hash of this file was at this date and time. But take it a step further. By a show of hands, who in here is familiar with the concept of fuzzy hashing? Okay. So there's a tool called SSDeep, and it does byte by byte hashing. That's known as fuzzy hashing. So basically, you get an MD5 of the file and then an SSDeep of the file. Now, if the MD5 matches, move on to the next one when you're doing your file integrity monitoring. If it doesn't match, Then compare the SS deep, and you can find the byte by byte where it changed. So it's basically a diff. So you can accomplish that via a very simple for loop. With the registry, catalog the registry keys. Get the creation dates when you can. You can script this as well. PowerShell should be able to help you do that as well. You can use regular expressions to parse the keys and the dates out of that. Another thing is probably get a hash of your actual registry hives themselves. That way you know when things change. If you have a very locked down system that regular users can't install things on, and it has to be a system administrator, and you only release updates once a month, then you can take that hash once a month and do a file integrity check. Hey, has anything changed in this registry in the 29 days since the last time we updated anything? If the answer is yes, then take a closer look, see what happened. I mentioned baselines earlier, and within volatility, there are three modules. You have process baseline, service baseline, and driver baseline. So process DL, driver DL, so forth and so on. And this is really, if there's one thing to take away from this, this is the part I would like for you to take away. So we hear all this talk about golden images and inventories, right? What does that consist of? Okay, a golden image, you have an image that you push to your entire network. What does it consist of? Well, your golden image is going to have all your software, it's going to have your configurations, your GPO, whatever. But with that, you should also be cataloging the specific software versions, any specific configurations, and all of that fun stuff. But what do we do beyond that besides just push it? Well, if you're using identical profiles, then you could actually capture a memory image of your golden image when you create it, save it, then push the image out, something happens, a machine is compromised, you can now take a memory image of it and compare it to your golden image's memory using the three baseline volatility modules. So instead of guessing what's supposed to be there, looking at your documentation at what's supposed to be there, now you have technical evidence of what exactly has changed within processes, drivers, and services. Keep in mind, though, that if you have a system like this Mac has 16 gigs of RAM, if I take a memory image of that, it's going to require at least 16 gigs of storage. So I'm going to have, I think they make 24 gig drives. I know they make 32. I'm going to have one or the other because you typically want at least 110%. So with that, I'm going to need at least that much space. And say, for example, within your organization, you have your standard baseline, your HR baseline, your IT baseline, your senior executive baseline. There's 4 baselines. So at 16 gigs, now you're talking, you've got to have 64 gigs of storage for this. Which, if you're doing it on a per golden image basis, that's very manageable. If you're a small organization with like less than 10 employees and a little bit of an appetite and budget for some cloud storage, you could do it to every host as well. But as you grow into larger enterprises, multinational companies, that's just not attainable. Seeing as using IBM as an example, they have 500,000 employees. Every employee is issued at least one computer. I don't even have an idea on the server count. Minimum spec on a computer right now is, 6 gigs of RAM? Maybe even 8 right now? And then you've probably got some people who have scratched and clawed not to upgrade their computer in a few years, and they only have 2 or 4 gigs. But 500,000 employees, and we'll just say on average 4 gigs of RAM, that's a pretty big data center just to maintain memory images. So it's not attainable. So that's why you go with the golden image. You can even script it if you want to do it on every host. But again, it's a storage nightmare. With PCAPs, they come from the same vein. Take PCAPs as often as possible for as long as possible and store for as long as possible. Again, PCAPs are going to take up space. They're not going to take up as much space as memory images, but they're going to take up space. Integrate with your SIM. If you're not using NetFlow, use NetFlow. We all talk, we may recall when Edward Snowden released the stuff about NSA, it was all metadata, and NSA was like, well, this isn't a problem, it's metadata. Well, what actually is metadata? So NetFlow collects metadata, and it's going to, depending on if you're using NetFlow version 5 or version 7, it's going to catalog who communicated with who, for how long, with what protocol, how much data was sent one way or the other, and all of that. That's a lot of useful information. If nothing else, it can help you identify anomalies and attack periods, specifically denial of services, because you're going to see those spikes. But NetFlow is the other thing that you can use to see that that job runs on the 13th of every month that spikes the network. So that's something useful. Logs, of course, PCAPs, vulnerability data. I mean, most SIMs allow you to import it if they don't have it already built in. I'm very familiar with Tenable's Security Center. I think it's like Nessus.io now, and Alien Vault's USM, and both of them actually have built-in vulnerability scanning components. So with your PCAPs, you can use things like Wireshark and Network Miner. Originally, I was going to demonstrate Network Miner, but I forgot and actually shut down my Windows VM that had it running. So I may be able to get it back up in time. But anyway, you can actually carve files out of packet captures using things like that. With Network Miner, it's so ridiculously easy, which actually brings us up to the demonstration period. So let me get that VM started. Oh, here we go. It's coming up quick. Just enter the password and then I'll change the view. If I can remember the password. Okay. Fortunately, I just fat-fingered. Oh, it ran updates overnight. Wonderful. So maybe not on Network Miner. Thanks, Windows. There's a reason I upgraded to a Mac. And it's saying this may take several minutes. So, okay, in the meantime, let's take a look at some, let me see if I can change the, no. So, just going to move this over here. Okay, I'll just leave it at that size. But anyway, this is just showing taking a memory image with FTK Imager Lite. So there you got to run as admin. And I sped up the process based on my research for the other talk I was talking about, the social forensication. Typically, I've determined that it's about 2 to 2.25 times the amount of storage in minutes. So 2 gig hard drive took me about 4.5 minutes. 12 gig or 2 gigs of RAM took about 4.5 minutes. 12 gigs took me right at 26 minutes. So very simple process with that. It's very point and click from the Windows environment. What you can do is on the external hard drive or the thumb drive, whatever you're using to collect it, if you know you're dealing with 16 gigs, walk up with a 32 gig drive. You can have FTK Imager on it already, FTK Imager Lite. It's an executable. Double click it, choose capture image. You can select if you want to go with an 81 or the pagefile.sys as well. Those are 81 is access data proprietary format. That's who makes FTK. Pagefile, there are some volatility modules you can do with it especially as well, but you're also going to get your memory file itself. So you can actually store to the same drive you're running it off of. So that's one piece of demonstration. Let me... Windows is asking a few questions. I'm having to opt out of all their privacy invasions. Just a moment. Okay, so I have that. I'm going to open Network Miner really quick in this. And just got to shrink the thing a little bit before I move it over. So here we've got, it's playing with parallels, so we really don't care about that. But this is network miner. I can't tell what that says, so I think it's asking me something about settings. But anyway, so with network miner, I can't tell what it says. Let's see here. No, it's not what I'm looking for. Still relatively new to the Mac ecosystem, so just bear with me a moment. So here we'll just load a file. So we'll open, and I don't have my glasses on, but this is documents, correct? Okay, it does. So we're going to go to desktop. I restored this from a Backblaze image. So here within this, we see a stupid icon. We'll move that over here. So we see the host that it communicated with. I apologize, I can't zoom in or out with this because this is the free version. For the paid version, you pay them like $1,300 and they send you a thumb drive. So I'm going to go with free 99. So we see the two hosts that communicated. We can expand that and see, we can go, okay, there's some addresses, additional information here. But what I really want to show you is right here, files. So notice nowhere in here do I have PuTTY installed. This is just a packet capture of an SMB transfer. So within this, what's that? Oh, yeah, thanks. I blow off notifications all the time. So let's see. You have to right-click it, and I'm trying my hotkeys for that here, and it's not cooperating. I go back to File. Okay, let's try this. Nope, that's not the droids I'm looking for. All right, one last shot, and I'll just... Okay. I'm going to double-click it and see if that works. And lo and behold, I actually have an external mouse with me, but I left it in the hotel room. See if we can do it over here. One thing we do see here, since this isn't working, is we have a hash of the file that was transferred. So if we're carving this from a PCAP that could potentially contain malicious data, we can actually get the MD5, the SHA-1, the SHA-256, and I think the 512. But ultimately, had I actually had my external mouse and had this actually cooperated with me, I apologize for not sacrificing to the demo gods. I'll do better next time, I promise. In right-clicking, and you would get a menu that would say view file, run file, or get hashes. So get hashes, that's where you're going to see more than the MD5. You can run the file, and what was going to happen is PuTTY's not installed on this VM. PuTTY was going to pop up. That's what was going to happen. But my right clicker is not working today, so I apologize for that. So coming back over for some more analysis, I've got a video that I have recorded of Windows 7 memory analysis within Sift. So I'm just going to pull this down here. And this is just going to run through very quickly. I'm setting the volatility location so that what this is going to do is it keeps you from having to announce to volatility every time you run it, specifically what the file is. And you can do the same thing with the profile. You have to define that every time. Here we, let me go back a little bit. We actually saw Mimikatz running. So the location, that's just saying the file, and it is 3 slashes. So we have that now. We run Mimikatz. So there's some passwords that were pulled from that. So NetScan, basically it's running netstat for you. Command scan, this is looking at everything that was parsed on the command line. Get SIDS, that's giving you all your user data. That right there is basically all your processes. So you're seeing what's running with this. Amcache, there's nothing there. So I created a directory to drop DLLs in. So this is just carving all the DLLs into that directory. We can do the same thing. We can dump RSA certificates, public keys, any of that fun stuff as well. So a little bit of everything. And so here's the certs. So there's all those public certs. You might be able to do something with those as well. And that's it within the Windows 7 environment. I've got a Windows 10 one here as well. And it's not quite as cooperative. We're going to get some stuff out of it, but we're not going to get nearly the treasure trove that we got with the Windows 7. So with this one, it's a slightly longer video, but we're going to do the same thing. We're going to export the volatility location and the volatility profile. With Windows 7, you denote it as Windows 7 Service Pack this underscore 32 or 64 gig. With Windows 10, you're going to have to put the version number after it, so you need to know what that is. There we ran Mimikatz. We got nothing on the hash dump. NetScan. Now we're getting some stuff there so we can see what's running and that fun stuff. Command scan, nothing. PS list, now we're getting stuff out of that, maybe. Yep. So it's the same things. PS scan versus PS list. It's just giving you different pieces of information that you can analyze in different ways. And I don't want to burst anyone's bubble, but when you're running this analysis, it's going to take a lot longer than this. I recorded it and cut pieces out and sped it up so that it would be for the sake of time. Same thing with the DLLs. We're able to get those. Just waiting on this to finish. It's just showing some of the stuff that you can actually take from memory that could actually be used proactively. All right, we're pretty much finished with this. All right, and go back to this. So we looked at network miner, we looked at the memory the memory acquisition, and we looked at volatility. Going a little bit further, I, alongside Brian Austin, co-founded a thing called Through the Hacking Glass. It's a mentorship platform. We're looking at doing it for system hardening, system monitoring, so like SOC, pen testing, and incident response, varying levels of complexity and difficulty. We've got about 300 people signed up right now, but only about 8% of those have signed up to be mentors. So regardless if you want to be a mentor or a mentee, feel free to sign up. There's the information for that. We're about to start pairing people soon. If you already have a mentor, feel free to bring them with you. But right now it looks like we're going to have to do it in cohorts. Upcoming speaking engagements, the nearest one to here will be Hack in Paris in June, where I will be presenting social forensication. So there's that. And then any questions? Questions, concerns, complaints, grievances?
Don't be shy. Any questions?
Anything? Okay, well, here's a coupon code for my upcoming OSINT training if you want it. It will be from 18 to 2200 CET on April 13th. It's a 4-hour introduction to social media OSINT. So if you use that coupon code, you'll get a discount. It's about a 33% discount if I recall correctly. So pretty decent. But if there are no questions, that's all, folks.